I never met Évariste Galois. He died 86 years before I was born. I never mentioned him in my lectures. Not once. And I should have, because his mathematics lives in every particle accelerator, every physics equation, every discovery we have made about how the universe works. And he wrote it all down the night before he was killed, 20 years old, shot in the stomach, left in a field to die. His opponent walked away. The seconds walked away. A passing farmer found him, alone in the grass, still breathing. The night before, knowing exactly what was coming, he did not run. He did not hide. He did not write letters to his family. He stayed up until dawn, writing mathematics. And here is what makes this a tragedy. Galois had tried to show the world what he had discovered 3 times. 3 times he submitted his work to the greatest mathematicians in France. The first one lost it. The second one died. The third sent it back, calling it incomprehensible. He was bleeding out in a field at 20 years old, and no one had ever understood what he had found. But I understood. More than a century later, I understood. Every equation I wrote, every diagram I drew, every particle I helped discover. That was him. That was always him. So why am I telling you about Évariste Galois? Because this is the story of what happens when you are right, and no one believes you. When you see something true, something that will change everything, and the world is not ready. Galois saw a hidden structure underneath mathematics, a pattern, a key that unlocks how the universe actually works. He was barely out of his teens. He was angry. He was completely alone. And in a few minutes, I am going to tell you about the night he wrote it all down, racing the sunrise, knowing he would be dead by noon. But first, you need to understand how a boy like this gets made. Picture a 15-year-old prodigy in a Paris classroom, bored out of his mind. The teacher drones on about basic arithmetic. The other students take notes. But this kid, Évariste Galois, is reading something else under his desk, a university textbook on geometry. He finishes it in 2 days. He reads it, he says, like a novel. Then he moves on to research papers, original mathematics meant for professionals. He devours them too. His teachers do not know what to make of him. One writes that the student works only in the highest realms of mathematics. Another writes that he has a remarkable spirit of research, but is sometimes obscure in expressing his ideas. That second part is going to destroy him, because Galois could see things no one else could see, but he could not slow down long enough to explain them. His mind moved too fast. His patience ran too thin. He came from a good family. His father was the town mayor. His mother taught him Greek and Latin at home. None of that prepared him for what was coming. At 17, Galois asked a question that had haunted mathematicians for 350 years. When can you solve an equation with a formula, and when can't you? Quadratics, easy. Cubics and quartics are ugly, but possible. But fifth-degree equations, nobody could crack them. Nobody even knew why they were impossible. Galois found the answer. Not just that you cannot, but why you cannot. He saw a hidden pattern beneath the equations. A structure, a symmetry. It would take the world 100 years to fully understand what he had found. And he was about to show it to the most brilliant mathematicians in France. Watch what they do with it. Galois submitted his paper to the French Academy of Sciences. This was it. The most prestigious mathematical institution in the world. If they recognized what he had done, everything would change. They gave his paper to the greatest mathematician in France, a man who had revolutionized half a dozen fields. If anyone could understand Galois, it was him. He took the papers home and lost them. Just lost them. Left them somewhere in his office and forgot. The most important mathematical discovery of the century, buried under paperwork. Gone. But that was not even the worst part. While Galois waited to hear about his paper, his father killed himself. The town priest had been forging documents, writing cruel attacks under his father's name, destroying his reputation. The scandal was too much. Galois' father hanged himself, just a few blocks from where his son was studying. A few days later, still reeling, Galois took the entrance exam for the most prestigious mathematics school in France. He failed, not because he was not brilliant enough, but because he could not explain his thinking step by step. He leaped to conclusions that took the examiners hours to verify. Legend says he threw an eraser at the examiner's head, the abandoned son of a suicide, rejected by the institution he had dreamed of joining. This is where another person might have given up. Galois got angrier. A year later, Galois tried again. The Academy announced a major competition. He rewrote his paper and submitted it. This time, it reached the secretary, another giant of mathematics. He took the paper home. A few weeks later, he died. Galois' paper was never found. Think about that. The same discovery, submitted twice, lost twice, not because it was wrong, because the universe seemed to be conspiring against him. Galois wrote bitterly about a society in which genius is condemned to an eternal denial of justice in favor of mediocrity. He wasn't just bitter anymore, he was breaking. Revolution exploded across Paris. Students took to the streets, but Galois was locked inside his school by the director, forbidden to join. When he wrote a furious letter criticizing the director, he was expelled. Now he had no school, no degree, no mentor, no father, just his mathematics and his rage. Galois threw himself into radical politics. If mathematics would not have him, maybe revolution would. He was arrested, acquitted, arrested again, this time carrying weapons at a protest, 6 months in prison. And here's the cruelest part. While Galois sat in his cell, he finally received a response to his third submission. The Academy had reviewed his paper. Their verdict was that his argument is neither sufficiently clear nor sufficiently developed to allow us to judge its rigor. Incomprehensible. 3 attempts. Lost. Lost. Rejected. Then he met her. A cholera epidemic swept through Paris. Prisoners were dying in their cells. Galois was transferred to a halfway house to wait it out. And there she was, the doctor's daughter. Young, intelligent, caught up in the same revolutionary ideals as Galois. For the first time in years, someone seemed to see him. We don't know exactly what happened between them. Only fragments survive, letters Galois copied obsessively, then scratched out, as if he couldn't bear to read them again. She was rejected, or she was caught between him and another man, or she was never really his to begin with. What we know, Galois was released from prison on April 29th. 1 month later, he was challenged to a duel. The challenger was a fellow revolutionary. The reason? Murky. Galois wrote that he was the victim of an infamous coquette and her 2 dupes. It doesn't matter why. What matters is this. Galois knew he was going to die. He was 20 years old, and he knew. And he had 1 night left. The evening of May 29th, 1832. Galois sat down to write. First, he wrote a letter to his fellow revolutionaries. He begged his friends not to reproach him for dying otherwise than for his country. He said he died the victim of an infamous cocotte. He asked pardon for those who had killed him. He said they were of good faith. Then he wrote to his closest friend. This is the letter that changed mathematics. Everything he had discovered, everything the Academy had lost, ignored, dismissed. He poured it all onto the page. The conditions for solving equations, the concept of a group, the hidden structures underneath algebra, new theorems, unfinished proofs, connections he could see but could not prove. He wrote about problems that would not be solved for another 50 years. He sketched ideas that mathematicians are still exploring today. In one night, racing the clock, he laid out a roadmap for an entire field that did not exist yet. The papers were a mess. Crossed out lines, insertions, arrows pointing to margins, the handwriting of a man racing against the dawn. In the margins, again and again, he wrote the same line. I have not the time. There is something to complete in this proof. I have not the time. Imagine him looking up at the window, the sky turning gray, dawn coming, the sound of birds, knowing that in a few hours he will be standing in a field with a pistol in his hand, and turning back to the paper anyway. Because what else could he do? This was all he had. 3 times he had tried to show them. 3 times they had failed to understand. This letter, this mess of scrawled notes, was his last chance. If he died and no one read it, everything he had seen would die with him. The mathematics mattered more than his fear. A mathematician named Hermann Weyl later said of this letter that, if judged by the novelty and profundity of the ideas it contains, it is perhaps the most substantial piece of writing in the whole literature of mankind. The most substantial piece of writing in the whole literature of mankind. Written by a 20-year-old boy, the night before he died, after being rejected 3 times. He asked his friend to send the papers to the greatest mathematicians alive. He wrote that after that he hoped some people would find it profitable to decipher all this mess. Early morning, May 30th, 1832. Galois faced his opponent with pistols. We do not know exactly what happened. The circumstances remain murky to this day. What we know is that he was shot in the abdomen. His opponent walked away. The seconds walked away. A passing farmer found him lying in a field and brought him to a hospital. His younger brother rushed to his side. Galois' last words were, "Don't cry, Alfred. I need all my courage to die at 20. He died the next morning. They buried him in a common grave. No marker, no monument. To this day, no one knows exactly where his body lies. For 14 years, nothing. Galois' friend tried to get the papers published. The greatest mathematicians in the world never responded. Then, in 1846, someone finally sat down and read through the mess of scrawled notes. They announced to the Academy that they had found a solution as precise as it was profound. They published Galois' papers. The mathematical world finally saw what he had discovered, and everything changed. The structures Galois found, the symmetries, the groups, the hidden patterns turned out to be everywhere, not just in algebra, in physics, in chemistry, in the deepest laws of nature. Every time a physicist asks what stays the same when everything else changes, that is Galois' question. Every time we predict a particle before we see it, that is his method. The mathematics he invented, desperate and alone, the night before he died, became the language we use to describe reality itself. I told you at the start, I never mentioned Galois in my lectures. I used his ideas every day, every symmetry I calculated, every diagram I drew, and I never said his name. Most physicists do not. We talk about group theory as if it always existed, as if it were just part of the air we breathe. But it did not always exist. Someone had to see it first. And that someone was a 20-year-old boy rejected by every institution, abandoned by every mentor, scribbling in the margins. I have not the time. I think about what it means to be right and alone. When I developed my own approach to quantum mechanics, some people thought I was crazy. Some asked, where is the proper formalism? Where are the differential equations? I was lucky. I lived long enough to see it accepted. I got to stand in Stockholm and receive a prize for work that people once dismissed. Galois never got that. He had 20 years, then a bullet in his stomach, and a common grave no one can find. But here is what I want you to understand. The mathematics did not die with him. 14 years of silence. Then everything changed. Someone finally read the papers, and they saw what Galois had seen. The hidden structure, the symmetry, the pattern underneath reality. His ideas spread through mathematics, into physics, into the deepest laws of nature we know. Every time we ask what stays the same when everything changes, that is Galois. Every time we predict something should exist before we find it, that is Galois. Every equation I ever wrote about particles and forces and the structure of the universe, somewhere underneath, that is a 20-year-old boy, the night before his death, writing faster than he could think. I have not the time. He did not have time. He was 20 years old. But his ideas, they had all the time in the world. Galois died in 1832. His mathematics lives in every particle accelerator, every physics equation, every discovery we have made about how the universe works. He lost the duel. He won everything else.